Properties of proportion. First, it is worth highlighting that in all properties of proportion explained in the following part, we will assume the main proportion in the form as shown on screen. The following properties are true for direct proportion. Swapping the means in a proportion still provides a proportion. In symbols, we know the following. For example, if 6/10 equals 9/15, then 15/10 equals 9/6. In the first case, both ratios have the value 3/5 when written in the simplest form, while in the second case the values of both ratios are 3/2 when written in the simplest form. The advantage of this property is evident when the terms in each ratio of the original proportion are difficult to deal with. Thus, when we swap the means we obtain fractions that are easier to handle, so the operations become shorter. Example 1. Prove that the proportion 33:54 is equal to 44:72 is true. Solution 1. First, we write the proportion in fraction form. We obtain the following shown on screen. We cannot simplify the fractions expressing the individual ratios in the actual form. Thus, we can simplify by 3 the fraction on the left and by 4 that on the right. Therefore, we swap the means to obtain fractions that can be simplified. Hence, we obtain the following. Now, the task is easier, as the fraction on the left can be simplified by 11 while that on the right by 18 to obtain the following. Since the two final fractions representing the possible proportion are equal, the original proportion is true. Swapping the extremes in a proportion still provides a proportion. In symbols, we write the following shown on screen. The purpose of using this property is again to make the operation simpler. Let's consider an example. Example 2. Check whether the fractions 7/24 and 21/72 are in proportion or not. Solution 2. One method could be simplifying both fractions by 3 and 7 respectively to obtain 3/8 in both cases. However, not everybody is able to figure out what is the GCF in either fraction. Therefore, we use the second property of proportion to write the following. Both fractions give 3 when simplified, so the original proportion is true. Inverting both ratios in a proportion still provides a proportion. In symbols, we write the following shown on screen. This property is particularly useful when the inverted ratios give whole numbers. An example of the use of this method, inverting ratios, in practice is when dealing with parallel combination of resistors, when we have to invert the fractions in the final step to obtain the result, as in the following example. Example 3. Two resistors, R1 equals 12 ohms and R2 equals 18 ohms are connected in parallel in an electrical circuit. Calculate the equivalent resistance of the circuit. Recall that the equivalent resistance rec of a parallel combination is given by the formula on screen. Solution 3. Using the previous formula, we can write the formula shown on screen. Using the method of adding two fractions with different denominators, we obtain the following. Now, it is the time to explore the advantage the third property that ratios offer. Inverting down the two ratios, fractions, we obtain. Adding or subtracting the corresponding denominator to the numerator of each ratio in a proportion still provides a proportion. In symbols, we write the formula shown on screen. Let's try a numerical example to confirm this property. Example 4. A. Prove that the proportion 12:30 is equal to 24:60 is true. B. From the result obtained in A, prove that 42:30 is equal to 84:60. Solution 4. First, we write the two ratios forming the proportion in fraction form. We have the following shown on screen. we use the first property of ratios, swapping the means, to make the operations easier. Thus, we obtain the following. Simplifying the first ratio by 12 and the second one by 30 yields the following. Therefore, the original proportion is true. Adding the denominators to the corresponding numerator of each ratio in the original proportion, as the fourth property of proportion suggests, yields the following answer. Applying the second property of ratios yields the following. The last expression is a proof that the new ratio given in B is also true. Another example with difference. The condition in this case is that the fraction must be improper, otherwise the difference becomes negative. To illustrate this property, let's take a known ratio, for example 4:3 equals 8:6. Hence, we obtain the following. The last proportion is also true, as when 2/6 is simplified by 2, it gives 1/3. Now, let's see an application of this property in practice. Example 5. Two brothers are 8 and 11 years old respectively. After how many years will the ratio of their ages will be 5:6? Solution 5. Let's denote the number of years to come until the conditions are fulfilled by x. Thus, we can write the following. Applying the cross product to remove fractions, we obtain. Using the distributive property of addition, we obtain the answer as shown on screen. Multiplying up and down one or both ratios in a proportion with the same number, they can be different in each side, provides a new proportion. In symbols the following is true. The condition for this property to be true is that both m and n must not be 0. In the previous examples, we dealt with this property silently by using division instead of multiplication because we wanted to make simplifications. However, since division is a multiplication by the inverse, it is obvious that this new property is also true. Let's consider an example to clarify this point. Example 6. Prove that the proportion 32:54 is equal to 80:135 is true. Prove that 96:162 is equal to 160:270 is also true. Solution 6. We use the previous property to confirm the ratio. Giving us the following shown on screen, the first fraction is simplified by 2 while the second by 5. Hence, we obtain the following. It is easy to observe that the proportion shown on screen is obtained by multiplying up and down the first ratio by 3, and the second ratio by 2, giving us the following. If we have the proportion shown on screen, then we can express it as the following. Example 7. The sides A, B and C of a triangle are in a ratio A to B to C equals 5:9 to 13. To each other and the perimeter, the sum of all side lengths of the triangle is 108 centimeters. Calculate the length of each side. Solution 7. Applying the sixth property of proportions, we can write the following. Thus, we obtain the following shown on screen. Moreover, we have the following. Therefore, the length of the three sides of the triangle are as shown on screen. We have silently used the sixth property of proportions too when explaining the definition of proportion in the previous tutorial. That is all for lesson 4.4.1. To continue this tutorial, please watch 4.4.2, calculating the nth proportional in a set of numbers. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.